Okay, Assalamu alaikum. So today we will be starting optics. So in your syllabus, Unit 3, we have especially 3 sections: SHM, then sound, and optics. So we are starting from optics. So here, there are a few important concepts you must know from maths. That's especially geometry. We deal with a lot of geometry in this section. So you must know the basic ideas of geometry. You might have studied in your O levels. We will be using them here. So under optics, first we will have to start with electromagnetic waves. So under optics, the first topic is electromagnetic wave. Electromagnetic wave. So we know what is an electromagnetic wave. So in an electromagnetic wave, we have two fields, a magnetic field and an electric field that will vibrate, that will oscillate in two perpendicular directions. The angle between these two fields is 90 degrees. So they are perpendicular to each other. And we call this as the electromagnetic wave. So this electromagnetic wave, I will be giving time. Okay. First, I will explain a little and then I will give the note. So you can note it down with me. Okay. So this electromagnetic wave, this is a type of transverse wave. We know, no, you might have not studied, right? If the energy or if the wave is propagating in this direction, but the vibrations are perpendicular to each other, we call them as transverse wave. So this electromagnetic wave is a type of transverse wave. Write down the topic, electromagnetic wave. Under that, draw this diagram. Draw it simply. So this is the direction of propagation and just draw two perpendicular fields. Okay. Once you have drawn, let me know. So here, this is the direction of propagation. Direction of propagation. Let's consider this as the magnetic field. The magnetic field, and the horizontal one then has to be the electric field. And the distance between the adjacent crest in your else you might have studied, right? Crest and trough. So the distance between two adjacent clefts, we call them as the wavelength, lambda. Wavelength. Once you're done, let me know. This below this, let's write down the velocity of EM waves is given by is given by the ratio between the amplitudes by the ratio between the amplitudes of electric and magnetic fields and magnetic fields. For electric field, we use the letter E. Okay? E with an arrow will show you electric field. And for magnetic field, we use B. So we use the letter C. For the speed of electromagnetic waves. Then C is equal E naught over B naught. So this is the amplitude, right? The maximum distance from this line, from this axis, that is the amplitude. So C is equal to E naught over B naught. As everyone completed the diagram. Next point, we also have another equation. The speed of EM waves also can be given by C is equal 1 over mu naught epsilon naught square root. Sometimes you are not might not have studied what is mu naught and epsilon naught. When you study unit 6 and 7, you will come across these two terms. So epsilon naught, we say, is the permittivity. Epsilon naught is the permittivity permittivity of free space. And mu naught, that is the permeability of free space. Under that, let's write naught number 1, velocity of EM waves in vacuum is found to be almost equal to 3 into 10 to the power 8 meters per second. Note number 2, when this electromagnetic wave, they travel from one medium to the other, then their velocities will reduce. The velocity of EM waves reduces when they propagate through a medium. Note number 3, all EM waves exhibit reflection, refraction, diffraction, interference, and polarization. You all may not have studied what is diffraction, interference, and polarization, right? But you will study when you're studying sound. Just before sound, you will be looking into these properties of waves. So reflection and refraction, you might already know from your O levels, but diffraction, interference, and polarization, you will study when you are studying the characteristics or the properties of waves. So you don't need to worry about those 3 terms, okay? Next, note number 4. This polarization, that is bit special. The reason is we can polarize transverse waves. but we cannot polarize longitudinal wave. So first we must understand what is transverse wave and what is longitudinal wave. We must get the difference between them. And then let's look at what is polarization. I hope you all not have studied polarization, right? Not yet studied, right? So let's go through, don't write this. Let's go through what is polarization. Before that, has everyone completed up to note 3? Yeah, I will explain. Not the same polarization, Hana, it's different. Up to note number 3, everyone is done, right? Okay, let's go through what is this polarization. First, we must know how to classify these waves. So don't write what I'm writing now. This is something additional that you will be learning in characteristic of wave, okay? When we take waves, waves are of two types. First one is the mechanical waves. First one is mechanical waves. And the other is the electromagnetic wave. Electromagnetic wave. So this mechanical wave, we can further classify it as longitudinal wave, and uh, longitudinal wave and transverse wave. So this longitudinal transverse wave is like this. When we have a wave that is propagating in this direction, we know these waves are vibrations. These particles vibrate perpendicular to the propagation. And in longitudinal wave, if this is the direction of propagation of wave, the particles vibrate in the same direction. They vibrate back and forth. And the energy is transmitted particle by particle. So that's the simple idea of these waves. So let's see what is this polarization. Polarization means we have a transverse wave. The transverse wave, we want to make sure we have a vibrator over here. We have a vibrator. This is producing waves in all the direction. It doesn't have a specific direction. At a time, it is producing vertical waves. At a time, it's producing horizontal waves. So it's producing waves in all direction. But I want only the waves that are vertical. I only want the waves that are vertical. For that, I have to filter. I need to filter. So this polarization works just like a filter. I have a cardboard. I have a piece of cardboard and a small slit. Now this string is taken through this slit. Okay. And again, I have another cardboard. Yeah. So I have a cardboard. The slit is in this direction. Just think, just imagine. Slit means in a cardboard, you cut a small piece at the center. Okay. So that is a small opening. So that's the slit. So now when you're vibrating up and down, this string can vibrate up and down through this cardboard. So you will receive the wave that is vertical. Think about the wave that is horizontal. Can the wave that is horizontal pass through the slit? Can it pass through? No, right? It cannot pass through that. So what we have done is we have filtered out the wave, the direction of wave which we need from all the other direction, other plane. So we call this as one plane and this as another plane. So here we have filtered out a specific plane from the other planes. So that is called as polarization. Filtering out a specific plane, we call it as polarization. Let's think about polarizing a longitudinal wave. So this is the longitudinal wave, and again I use the same piece of cardboard, same slit. As the molecules is vibrating back and forth, this is vibrating back and forth, can I filter out? Can I polarize any of the plane? If it is a if it is a longitudinal wave. Yes, Najma. So here, this slit will be in the direction that you want. For this example, I considered a slit which is vertical. So if you had a horizontal one, it will only polarize the horizontal plane. It will give you only the horizontal plane. It will filter out all the other planes. Okay, got it. So we can polarize transverse wave. Transverse wave we can polarize, but longitudinal wave we cannot polarize. And then we have this EM wave. This EM wave we are able to polarize. The EM wave we are able to polarize. So what type of wave is EM wave? Now we go in reverse. First we understood if it is transverse we can polarize. If it is longitudinal we cannot polarize. And then we have this EM wave. We are able to polarize. Therefore, EM wave has to be transverse. It has to be transverse. So that's the idea, okay? You will be studying about polarization when you study sound. So you don't need to worry a lot. And I'm not giving a note related to that because you will be studying, okay? Then we have this permeability and permittivity. To understand that idea, you need the idea of electric field. So I'm not discussing about permeability and permittivity here, okay? So the next point, we can tell the ability to polarize EM waves proves that they are transverse waves. They are transverse waves. So just search the internet for polarizing filter. Polarizing filter. To take photographers, they all use this for cameras. So they will get only a certain plane. Then the image will have more clarity. And you might have heard about these polarized sunglasses. So when you put on those polarized sunglasses, uh, the light will reduce. The intensity of light will reduce. What you see will reduce. So just surf the internet about these, okay? So note number 5, we have two fields. We have two fields in electromagnetic wave. One of them is the magnetic field. The other one is the electric field. And most of the characteristic this electromagnetic wave shows, like uh, affecting the photographic paper. You know what is photographic paper, right? these X-ray cards and all. In these X-ray cards and all, when this light hits, it turns black. Okay, when this light hits, it turns black. So they spoil the paper. We say they affect the paper or spoil the paper. Okay, so these characteristics are due to the electric field. Most of the characteristic EM wave shows is due to the electric field. Therefore, we consider the plane of the electric field as the plane of the EM wave. So here the plane is horizontal. Therefore, the plane of the EM wave is also horizontal. So let's mention it in our note number 5. The plane of vibration, the plane of vibration of EM waves, of electric field, of electric field is taken as the plane of the EM wave. Since it is responsible for most of the characteristics of EM waves. Note number 6, as we mentioned earlier, the vibration doesn't occur in a single plane. Okay, so here, Najima, we have two fields, right? From electromagnetic wave, we have two fields. One of the field is the magnetic field. The other field is the electric field. Now, this is one plane. Here, this is the vertical plane in this case, and this is the horizontal plane. The other one is the horizontal plane. In the horizontal plane, let's say this is my electric field. So my electric field is in the horizontal plane and my magnetic field is in the vertical plane. For some situations, we might need the plane of the electromagnetic wave. What is the plane of the electromagnetic wave? That is the question now. What is the plane of the electromagnetic wave? So we don't have a single plane. We have, for this single wave, we have two planes. We have a horizontal plane, we have a vertical plane. So what we are going to do is, we are going to consider the electric field's plane as the plane of the electromagnetic wave. Therefore, the plane of the electromagnetic wave is horizontal. Just like direction. If I ask you what is the direction of this plane, direction of the wave, you will tell it is moving towards your right hand. And if I ask you in which plane is it vibrating, in which plane is the electromagnetic wave vibrating, then you would say it is vibrating in the horizontal plane, because in that plane only we have the electric field. Why are we selecting the electric field, not the magnetic field? Uh, most of the characteristic the electric field shows, most of the characteristic the electric field shows is due to this, sorry, most of the characteristic EM wave, EM waves shows is due to electric field. No, Hana, you can consider the other way also. So you can consider this one as the electric field and this one as the magnetic field. Okay, it can be in any plane, not only horizontal. It can be in a plane like this, a plane like this, and you can have one of the plane, the angle between these two is 90. Let's say this is the electric field, then this will be the magnetic field. Got it, Hana?